In this video we have the integral of 1 over x multiplied by the square root of x squared plus 4. And it's possible to use a u substitution. However, I'm going to use a trig substitution. So I'm going to let x equal to 2 tangent of theta. So remember, this implies also that tangent of theta is equal to x over 2. Take the derivative here, respect to x, then respect to theta. On the right side, I get 2 dx is equal to 2 secant squared theta, d theta. So for the x, that's going to be replaced by 2 tangent theta. And then the square root of x squared plus 4. Remember, we have to transform this into a variable involving theta instead of x. So here, let's find a representation for the square root of x squared plus 4. Remember, x is equal, by substitution, 2 tangent of theta. So if I plug that in for the x, 2 squared is 4. Then I square the tangent, I get tangent squared theta. And then I got the plus 4. So I can factor out a 4 from the radicand here. And that'll give me the square root of 4 outside the radical. So that'll be a 2. And then inside, then, factoring that 4 out will leave me tangent squared theta plus 1 under the radical. By your trigonometry, tangent squared theta plus 1 is equal to secant squared theta. And then we take the square root of secant squared, we get secant theta. So now we come back to this integral and make the substitution. Dx will be 2 secant squared theta. In the denominator, the x, remember, is replaced by 2 tangent of theta. And then the radical, square root of x squared plus 4. Simplified, we got 2 secant theta. So let's do some cancellation here. This 2, say, and let's say this 2 will divide out this secant here. We'll divide one of the secants on top, secant squared, so this will just be a 1 here. So let's have it this way. The 1/2 will be out in front. Everything cancel the 1's there, and then we got the 2 here. So we got 1/2, and what's left here? Well, we got a tangent in the denominator, so if we take that up to the numerator, because tangent and secant, or tangent and cotangent are reciprocals, that will become a cotangent of theta in the numerator. And then numerator got secant of theta. Secant and cosine are reciprocals, so this will be 1 over cosine. And then cotangent theta is cosine over sine. Cosine over sine. So the cosine and this cosine will cancel. So that'll leave me 1 over sine. Okay. Got cosine. Cotangent is cosine over sine. And then we got 1 over cosine. Whatever cosine theta, we got sine theta here, and this will cancel. So that would, this then simplifies into 1 over sine, but sine and cosecant are reciprocals. So I can rewrite this as the integral of cosecant of theta, d theta. And there is a formula for this integral that most instructors would expect you to know. There's also one for the secant. And I believe I could write both of these in another video. But here's what we have then. We got the 1/2 on front, that's constant. And the integral of cosecant of theta, d theta, is the natural log. And there's one where it's a minus here, minus, and then the natural log of absolute value of cosecant of the angle plus cotangent of the angle. And if you simplify that, bring the negative over here and use properties of log and so forth, this becomes the integral of cosecant of theta minus cotangent of theta, and then it's plus the constant of integration. So again, there's one that gives you a formula that would be a negative here in front of the absolute value, because remember the 1/2 is just part of this problem here. It's just constant out of here. And this would be a plus here. And then there's the one that just has the plus here, because all they did was take the negative and put it over here using the property of logs and got this formula. So this is the one we're using. The integral of cosecant of theta is equal to the natural log of absolute cosecant of theta minus cotangent of theta. And of course we got the 1/2 as a constant. So that's pretty much the answer in terms of the variable theta. But we have to go to the original variable. So we'll look at our reference triangle here. Right triangle. This is then theta. And from this right here, tangent of theta is divided by 2, x over 2. So this would be an x here. And this would be a 2 here. And then we complete the hypotenuse here. It would be the square root of x squared plus 4. So now we just rewrite this in terms of the variable, the original variable x. So let's go this. This will be natural log of cosecant of theta. So let's look at the triangle here. Cosecant is just the opposite of sine. So it's the hypotenuse, square root of x squared plus 4 over the opposite. Sine is the opposite over the hypotenuse. Cosecant is opposite over the opposite side. Hypotenuse over the opposite side. So that would give me then the square root. So the cosecant of the angle then is the square root of x squared plus 4 over x. And then it's minus the cotangent of the angle. Cotangent is the adjacent over the opposite side. Adjacent is 2, opposite is x, so this will be 2 over x, plus the constant of integration. So you can leave your answer this way, or you can put these together as one fraction since we have the same denominator here. So we could just write it as one fraction. We could give this answer: 1/2 natural log the square root of x squared plus 4 minus 2 over x. So again, this is x squared here plus 4 under the radical. Final answer. Thanks for watching. We'll see you next time.